Well, hi everybody. I'm back, and hope you all had a little bit easier week than I did. It's been quite a busy week at work, so I have had absolutely no time to even look at anything on the bench here. So it's Friday, and I thought, well, I'd come down here and play a little bit. So this is our fifth and final part to our SX1050 restoration, and we're finishing up with the multiplex adjustment. Now, we got into a little bit of theory of how multiplex stereo works when we were working on the FM tuner alignment on the last part 4, and today we're going to try to put some of that theory into practice and see how it actually works on one of these stereo receivers. Now, the first thing you need to know is there's a lot of different ways they design these tuners. This generation, which is mid to later 70s, you'll see that if we look down here, you start to see the use of integrated circuits, okay, in the stereo. So we got an IC here, we have an IC here, we have one here. So basically, these are taking the place of a lot of discrete components you would have seen on the older generation tuners. Now, that's a very good thing, because if you look, this tiny little board is the entire AM and FM stereo multiplex tuner assembly, all in this one little board, which is great. The other thing is, a couple of these chips in here serve multiple purposes. So before we get into the alignment, maybe we'll talk a little bit about how this circuit works, and then maybe it'll make a little more sense of what we're doing here. Okay, so let's get a couple things up here and we'll take a look. Okay, so we're going back to the block diagram of the SX1050, and we're going to focus on this tuner section up here a little bit, and you'll kind of have to forgive me if I don't post a bunch of pictures and stuff in this video. I'm going to just keep it simple on this one and get a little more into the meat and potatoes of doing this job. But as we said earlier, you have your RF amplifier, you have your mixer to make your IF, you have your local oscillator, and these two frequencies beat together to make your intermediate frequency, which is 10.7 megahertz. It then goes through some filtering and some amplification. You can see these little these little filters here. And if you recall if you want to go back and look at my SX750 video, one of these filters actually went bad and caused the receiver to be deaf. But so these basically shape that signal. They take out all of the everything that's not 10.7 megahertz, okay? So it narrows that bandwidth to get rid of noise, okay? And also to narrow us down to only our signal that we're interested in. Now, from there, you go into a whole bunch of things that they kind of skip through an awful lot, showing like this integrated circuit here. It goes into a ratio detector here, and it comes out with your basic FM, but then it also goes into an anti-birdie filter. Birdies are when you have extraneous what should I say, signals, AC signals that beat against your normal signal and create a beat frequency, which would be a sound. It almost sounds like a bird tweeting. Those are called birdies, and we don't want those, because those come up as noise, as squealing in the background of your station. So this circuit is just to filter that out. We go into our multiplex detection, and you see your little relay there, and then your low pass filter, and once again, all these things all take place kind of different than this block diagram is showing. But it's a very kind of a simple idea of how we're doing it. We're taking our signal, we're taking it to 10.7 megahertz. It then gets what we call limited. A limiter circuit is something that removes the amplitude modulation component of your FM signal, and that gets rid of all the noise. That's why FM's so quiet. But then when we strip away the carrier signal, which is your 98 megahertz, station, and we want to strip the audio, then that audio becomes amplitude again. Okay, so it'll make a little more sense here when we see it on scopes and things. Now, going into the actual schematic, let me go back down. Again, we see a little better, little more detail of our tuning circuit. So our tuning capacitors and our mixer, okay, going through our limiter, becoming 10.7 megahertz, getting filtered and amplified. This HA1201 is just a little RF amplifier, like a preamp. Once it gets filtered, it goes into this chip, and it's the description of this HA1137 is an FM-IF chip, or an IF function chip, intermediate frequency function chip. But it's really everything all in one chip for your tuner. So I wrote down here a few of the functions that this chip has inside of it, in this tiny little chip. It's the limiter, which is the thing that gets rid of the amplitude modulation from your FM signal. It is the meter driver for your center of tuning and signal strength meters. So all the circuitry to make those meters work is inside this chip. There is a quadrature detector that is used for the detection of like your multiplex and so forth, but it's not your multiplex chip. And it's also got your muting circuit, your AFC, or automatic frequency control, your multipath, and even an IF amplifier, all built into this one little chip. Okay, so as you can see, all these things go out. So for instance, you have your tuning meters right here and here, okay, pins 5 and 6. You have power coming in, you have your multiplex out, you have your B plus coming in, you have your actual FM signal coming out that goes through this ratio detector. All these things are being done inside one chip. That would have been a whole big bunch of circuitry just in and of itself if this chip wasn't in here. Okay, so then we have another little RF or another little IF amplifier, and then we go through detection. And then when we get down into here, this is where we're doing our demultiplexing. Okay, so, and this particular demultiplexing chip uses phase lock loop to lock in on your carrier, your 19 kilohertz pilot, and all the other things we showed in the last video. And it actually will separate the right from the left by doing the left plus right minus left minus right, and so forth. That little math formula that I had on that one clip on my last video, and it subtracts the two side bands on the 38 kilohertz double sideband suppressed carrier signal that sits above the 19 kilohertz, and separates it into your left and right signals. Okay, so how do we adjust all of this? Okay, it's actually pretty simple. It's complicated when you read it if you don't understand what they're saying, but it's actually not a hard process. And this is what we're going to get into. And by the way, if you know how to do this process on this tuner, this will work on most of the analog tuners from Pioneer. Okay, they're all very similar. The older ones may not have all the chips, or may have different things. The newer ones may be a little bit different, but they're all very similar design. Okay, And like for instance, the 50 series, like the SX1050, 450, 550, 650, 750, 850, 950, 1050, all the way up, all of those use this same principle for multiplexing or demultiplexing. So this one page is all we need, okay, in order to align our FM multiplex or our stereo. And you can see there's 8 steps and one little diagram that hopefully, if we can get this to work right, we should be able to reproduce this pattern on our oscilloscope. Okay, so let's read. It starts out by saying connect measuring equipment as shown in figure 31. So figure 31, good old disorganized Tony here. And by the way, when we were talking about the sidebands and the 2 math formulas, that's this right here. So you're taking the sum plus the difference and the sum minus the difference of those 2 sidebands and so forth. Sideband with the mono signal. Anyhow, let's see if we can find figure 31. Okay, so here's figure 31. And as you can see, once again, they're just using the outputs from your tape outputs to go into a AC voltmeter and a distortion meter. Okay, and this is for the basic FM alignment. But for this first part, we're going to use this bottom part of this diagram, and as you can see, we're taking an FM signal generator and we're going to drive 300 ohms dummy load. We're going to drive an unmodulated signal right into your antenna jack. So if you look back here, I just have a 300 ohm balun. Here, you're not seeing. Right here, going into the back of the tuner. And it's just going right up to my signal generator. Now this doesn't have to be FM, AM. There's no modulation. They just want a 98 megahertz sine wave at 1 millivolt, which is 60 dB. Okay, that's all. They just want a 1 millivolt drive signal at 98 megahertz going into the tuner, and they want you to tune your receiver to 98 megahertz till you tune in that carrier. If you turn the volume up, all you should hear is silence or a real quiet hiss in the background when you get on top of that 98 megahertz with your tuner. Now, and then they also want us to take our multiplex signal generator, and they want to wire let's read it so you see what I'm saying. It says connect the output signal 19 kilohertz of your multiplex signal pilot out terminal to the horizontal input of an oscilloscope, and pin 22 of the tuner assembly to a probe to the oscilloscope vertical. Now, what are they talking about when they're saying horizontal input and vertical input? What does that mean? Well, in order to do this particular measurement, you have to set your oscilloscope to what's called XY mode. Okay? Now, this is something that almost all oscilloscopes have. Even the old oscilloscopes, the old analog oscilloscopes even had this. But it's something that most people don't really look at or use or understand. And really what it is it's kind of turning your oscilloscope into similar to a television, where you have a vertical deflection signal and a horizontal deflection signal. Okay? So if you look over here at this oscilloscope, okay, I'm going to show you here. If you look at this oscilloscope right here, I currently have my scope set to XY. Okay, now on these Tektronix scopes, the menus are a lot more complicated than on, for instance, this oscilloscope. Now this is an old analog scope, and I'm going to zoom you right in on the seconds per division. And if you look at the seconds per division, if you rotate this seconds, your time knob all the way to the left as far as it'll go, you'll see this little thing down here that says XY. that's where you want to turn your scope to, okay? On this one, and your scope may be different. If you have one of these newer scopes with the LCD screens and all that, even the cheaper ones like the little $200, $300 O1 that I showed you in another video, they all have XY mode. You just have to get in there through a menu, okay? And what that did is, if you notice, I don't have any signal going into this scope right now, okay? You can see this plug's unplugged, and this one's really not, there's nothing coming in here. And you can see I have a dot right in the middle of the screen, okay? Let me zoom you in. Okay, so I have a dot right there. And what you're going to find out is when I put a signal into channel 1, it's going to deflect the dot right and left. Positive voltage will drive it this way, negative will drive it this way. And when I put a signal into channel number 2, it's going to drive it up and down, positive and negative, okay? So basically, you're looking at two different directions, and you're basically going to draw a waveform, and we call that waveform a Lissajous pattern, or an XY pattern, okay? And they actually spell it down here. It's a Lissajous pattern, okay? And you can look these up. There's a lot of information on the internet about oscilloscope XY mode and Lissajous patterns. Okay, this is the same setup that we're using, like when I was using the I did the video on the curve tracer, the transistor curve tracer. Again, it has a dual output for X and Y mode of an oscilloscope, and it presents a Lissajous pattern. Same thing. It doesn't look like this, but it's still a XY pattern. Now, what they're saying to do, in just a little more complicated language than it needs to be, is they want you to put a 19 kilohertz signal into your scope. And you're going to beat that 19 kilohertz against the signal that we're monitoring in your tuner on pin 22. Okay? So that's what they're saying, multiplex signal generator pilot out terminal, okay? Not everybody's signal generator is the same, and I can tell you right now, you could literally use a regular function generator, and you can just put a 19 kilohertz sine wave right into this, into this scope, and it'll work just fine. You don't need something fancy. Now, the way I'm doing it here is I'm using, as you can see up here, I'm using my SG1050, and I'm coming out of the all signal output, okay, you see it, and I have this thing set to multiplex signal right here, and when you do that, it is going to just generate a 19 kilohertz tone. Now look up here, 19 kilohertz pilot. When I toggle that switch on, that actually is what gives us our 19 kilohertz pilot. Okay, so it just puts out a sine wave. All right. By switching these two switches, I'm putting my double sideband signals out at the 38 kilohertz, and I'm making a 400 hertz tone on the left and on the right, or both if I turn them both on. So this is a really useful little machine here. But for this first part of this alignment, you do not need this. All you need is 19 kilohertz, nothing else. So to show you, I have this scope turned on, and you can see, I'm going to zoom real close in. You can see right here that it is just a basic 19 kilohertz signal, but there's these little pips on here. Those are actually part of your multiplex signal that this signal generator puts out. Now, you don't need those for right now. They don't need to be on there. Those are kind of used as markers, but they don't have to be there. And what's more, if I take and turn on that left modulation or right modulation or both modulations, that's taking those signals and modulating them to make the total multiplex signal. But right now, we're only putting the 19 kilohertz. Are you following me so far? I'm just doing this to show you guys what that signal is coming out of that SG1050. It's a sine wave. Ignore those little pips. It's just a 19 kilohertz sine wave. So if I unplug this now, and I move it down here to this scope, okay, watch my dot. You can see that sine wave is just moving that dot side to side. When it swings positive, it moves the dot this way. When it swings negative, it moves the dot this way. Okay? And it's just doing it 19,000 times a second very quickly. Okay? And you can see the frequency is 19 kilohertz. Okay? There it is. So far so good, guys? This isn't so hard. Okay. So now, our next step is we want to connect the horizontal input, which is that little probe right here that I have, onto pin 22. Okay, so if we move this down to pin 22, there you go. Okay, and when I turn on the stereo, see, there it is, we should see something that looks like this. But what you're going to find out is we live in the real world and this is in the fantasy world. So here we go, and you can see it is that signal. Now I'm not locking into it perfectly. Okay, this scope, there's a lot of things I could probably do with the triggering and so forth to get it to lock in perfectly. But you can see for the most part, if I back up, the signals look pretty similar. Okay, now I haven't adjusted anything yet. Okay, so the next step is adjust VR3 so that the Lissajous pattern becomes stationary. So what they're saying is they want it to sit still. Okay, and according to this, VR3 is right here. Okay, which is right down here next to where we're plugging our probe. So if you look there, we have VR3. Okay, now I can take and adjust this a little bit, and we can see if maybe I can get it to line up a little bit better. Okay, make it a little more stable. So let's look. We're just getting this thing to lock onto the pilot signal right now, and I'm probably not going to mess with this too much because it's on. But if we adjust it, I'm just going to turn it a little to see what it does. See how it affects it, and see how it gets. What you want to do is you want to adjust it until you have the least amount of noise. And you can see right there we're getting pretty close. Okay, so and it's going to jump around a little bit. You just can't get around that. There you go. And that's about all we're going to, that's about as good as we're going to get it. Okay? So there it is. And you can see that was pretty close to begin with. Okay. So all you really, what were we just doing? You were just setting this thing to be able to, so that the pilot signal is correct. Okay? So that you're basically setting this to be tuned to 19 kilohertz exactly. Okay, so that part's done. Now the next thing we're going to do is we're going to put our signal generator to 67.5 kilohertz deviation at 1 kilohertz for left and right channels. Now I don't have a 1 kilohertz deviation signal on my SG1065. Mine is a 400 hertz, which doesn't matter. It's all the same. It'll still work. Okay? And a 7.5 kilohertz deviation for the 19 kilohertz pilot signal. Okay? And so basically what we're going to do now, and then we're going to go ahead and we're going to adjust for minimum distortion. Now, do you notice what happens here? They really don't tell you what's going on. If we just did this right now, the way that this SG165 functions, this would not work because, of course, I have my signal generator plugged into my scope and not into this machine here. Okay? So they have a little bit of different piece of test equipment. Okay? And you can see how they're doing it is they're using a signal generator with a modulation in and then with a scope out. It's a little bit different. They have two pieces, whereas mine's a little bit different setup. Okay, so what I'm going to do is I'm going to take that 19 kilohertz signal that is plugged into the scope right here, and I'm going to set it up as a multiplex signal right here on my scope. And as you can see, once again, that's what it looks like. We're not going to lock into that too easily now, are we? Okay, and we have to change our frequency, and you can see what we have now is our modulated, hold on, that's our modulated 67.5 kilohertz multiplex signal. And you can see the scope's having a hard time staying locked on and everything. There's a lot going on in there. Okay, but what we're going to do now is we are going to take that signal. Let me back up so you can see what I'm doing. And you can see the external modulation input to my signal generator, and we are going to place it right like that. I'm just plugging them together. So now we have the SG165's output plugged into the HP's input. I'm going to turn on FM modulation, and I'm going to set it to external modulation. Okay, there it is. And you can see the red light kicks on. That we have modulation set up. And I have internal shut off now. Okay? So you can see external FM modulate, high external input. So that red light tells it that there is a signal coming in. Okay? There you go. Back to here. And what they're saying now is we should have a stereo light coming on right now. And we're going to take our scope over here and connect it back up to those tape record outputs. And we're going to take this out of XY mode. So we're going to go back to normal mode. We're going to take our probe off. Okay, off of pin 22, and we're going to have our right and left channels right here plugged into the right and left channels of our scope, like that. And as you can see, there is our signal. Okay? All right. And if you look, that's a 400 hertz tone roughly. It's 379, but that's your 400 hertz tone. Okay, and let's see if we can expand this a little bit to make it easier to see. All right, and we're going to, and again, you guys, if you have a harmonic distortion meter, or a distortion meter, or you have a scope that can do FFT or anything like that, there are other ways to measure the distortion. But I'm going to show it the easy way for you guys, so that with a simple oscilloscope you can do this like an analog. Basically, we're going to adjust this for minimum distortion, which you could see we're already there. Alright, and it says adjust the T5 core for minimum audio frequency distortion. Take care to turn the core only within 180 degrees, plus or minus. So they don't want you moving it more than a half a turn either way. And then they want VR2 for minimum signal leakage between channel right and channel left. Okay, and from left to right. Okay, so basically all we're going to do is 2 adjustments. So really there's only 3 adjustments for this whole thing: VR3, T5, and VR2. So if we look once again, T5 is not listed on this page. Hold on a second. Oh yeah, it is. I'm sorry. T5 is this one right here. Okay, and this is your IF transformer, and we already adjusted this once before, I believe. Maybe we didn't. It's been a while, guys. So let me find the tweaker. Okay, we have the tweaker down in there, and I can tell you this doesn't need adjusted, but you see your 2 400 hertz tones, and if we turn the volume up, let me see if I can get this. This is a stereo mic on this camera. See if we can hear, and you can see there we go. There's your 400 hertz tone on channel A and channel B, or right and left, and there they are. So all we're going to do is we're going to rotate that tweaker, and we're just going to make sure that there's as little noise as possible on this. And of course, we're not going to mess with it too much because it's pretty darn good how it is. Okay, so there we go. Next step, we're going to adjust VR2 for minimum signal leakage. And again, it's on. We don't have to mess with it. But VR2, which is the one right next to VR3. So it's this one right here. And you'll just adjust that till you get minimum signal leakage. Okay, and again, see how it, if you get off, it goes out of sync. So you just kind of want to center it till it's real stable, until the signal looks perfect like that. Okay, and that is really all there is to the multiplex adjustment on this receiver. And once you understand what's going on, it's a 2-step process. I mean, you're setting that 19 kilohertz pilot signal for detection in your first adjustment and lining it up, and then you're actually adjusting your right and left from that. And I'm dropping everything here. Okay, so that's really all there is to it. It's aligned. So we should be able to connect this up to an antenna, and again, we should be able to pick up some stereo. And we already demonstrated that on the last one, but we'll do another run down the dial here. Okay, let's start down at the bottom and just see what we can pick up. Once again, I don't have the best reception where I live, but okay, and keep your eye on the stereo signal, and we can see how low of a signal it'll still go stereo on. And you can see that's almost 0 signal level, and it's still picking up the carrier and going stereo. Now, let's talk about stereo for a minute. Stereo requires a lot more signal strength than mono, because whenever you get that double sideband suppressed carrier signal, there's a large degradation in signal strength. That's the trade-off. So what you'll find is when you're listening to that signal that's carrying above the 19 kilohertz pilot, which is your right and left signal data or information, it's going to be a lot weaker signal sounding than when you're listening to that 0 to 15 kilohertz mono signal. So we can demonstrate that by switching between stereo and mono on this, okay? And you'll see the difference in clarity when we look at the mono part of the carrier than when we're looking at the multiplex part of the carrier. So let's listen. Here's the stereo. And you can hear all of the static, right? Now watch when I turn it off and go to mono. Not a big difference. Hear the difference? There's stereo, mono. Stereo, mono. Okay? So that just gives you an idea.
Daily basis. More information about Dutchman Hospitality Group is available at our website, moodyradio.org/Cleveland.
Yeah, just like
Kevin is my throne.
100 feet.
Heroin and prescription drugs.
A superstar, let alone that level of superstar.
The same distillery there down here, Black Dog.
Okay, now if we turn on the muting circuit, and we'll hear how quick it pops. Okay. And you can see you have to have a lot more signal strength.
Part of the funds will go
With local and regional snails on demand. More information.
And you can see how it just pops right onto the station. See that? Even weak stations are coming up pretty good. And that's how you know you have these aligned right, is when you're going down the dial with the muting on, when it just pops perfectly right in. Doesn't fade, it just pops. Just like that.
On the Fast Ready page at 93.3 FM.
So you get the point. These are really good receivers. That's all I can say. You just have to know what you're doing with the alignment and take your time. And these can really be good receivers. So once again, don't be afraid to do an FM alignment. FM really isn't FM. I think if you watch my last video, you'll know what I'm talking about. It's science. And again, don't be afraid of it. It's just kind of an extension of AM, really. And when you look at an FM tuner, you're really looking at the building blocks of an AM tuner. I mean, think about it. When we come in here, it's still just a carrier signal with information on it. It's being modulated differently, but it's still a carrier signal, and it's still a resonant tank circuit. And you're still tuning with a capacitor and a coil, which is a tank circuit. And when it resonates with the station that you're trying to tune in, it passes that information in here. It goes through a little RF amplifier, gets turned into an intermediate frequency. Now instead of 455 kilohertz, it's 10.7 megahertz. Big deal. It's the same idea though. Some of the things we do after, you know, after we pick off that that signal of the audio, okay, is a little different, especially with stereo, because once again, you have a lot of information in there that you're taking apart, okay? You have more than just a simple modulation, which is just a simple audio signal. You have a complex signal that has multiple things carried on top of one another, and you're basically using different filtering to separate all that and different tricks to take them apart. But it's really not that difficult, and just a little bit of thinking and a little bit of concentrating, reading the instructions. I think the biggest problem that I had learning FM was instructions like this that tell you things about, you know, how, not being specific as to how you connect your test equipment. I mean, they're assuming that you're using the same test equipment that they used at the factory, and there's lots of different types of equipment that you can use. So I had some people ask me, you know, how do you afford this kind of stuff if you're on a budget? Well, you can. This isn't just the only equipment out there. You know, I purchase a lot of my equipment used, my test equipment. Some of it I like to purchase broken and I repair it, and that's really where I get my most savings. But like this HP makes a whole line of these, not just the 8657. There's a whole ton of them, and they're all the same. They have, some of them have knobs, some of them have buttons. Some of them are a few years older than this, some of them are a few years newer than this, but they all do the same thing. They make a RF carrier and they modulate it. Some of them can modulate AM only, some of them can modulate AM and FM. The FM ones are a little more, of course, they're going to be, but not a whole lot more, especially if you get older ones that are used. And they're very versatile. You could see how much we did with just that simple thing. And then by using just a regular function generator like this audio generator here, I could put 19 kilohertz into here and set up my pilot, and I can make my Lissajous pattern. So it's pretty simple. Technically, if I wanted to, I could have used this and just put a regular 98 megahertz carrier out of this, because it didn't have to be modulated to do this multiplex circuit at first, you know, the first part anyways, and I could have put this 19 kilohertz here down into my scope, and I could have done that first step just with something as simple as that. Now, if I wanted to, this is where we're going to get confusing. This is capable of doing everything that I just did with my other signal generator. Okay, it's a little different setup. Yeah, you have to use all three of these jacks, but technically we could have set it up that way. This is an oscilloscope output, and this oscilloscope output actually goes to the horizontal of the scope the same way. This all signal output would have gone into the antenna. This from detector signal would have come from my detector probe and either gone, you know, back into the scope or back into there, or, you know, come out of the test point down here, depending how you do this. And again, we could have easily done this whole setup using this. This has an RF generator in it, you know, for the sine wave part. It has the multiplex output. It has the pilot and the right and left multiplex. So very versatile machine if you have one of these. And these can be had, I mean, they're not cheap, but if you shop on eBay long enough, you know, and check some of the old TV shops that are shutting down, they're out there. And this does everything, you know. So that's another way to do it. Let me show you even another way. So here is a very nice piece of test equipment made by RCA. It's very old, believe it or not. Called the WR52A Stereo FM Signal Simulator. And if you notice, this has all of the different signals you could possibly think of. It has a composite signal audio, which is your total multiplex. It has a straight RF output. And now the way they do it is pretty slick. They just start at 100 megahertz center frequency, and you can go up or down from 100 megacycles. So technically, we could have done this same adjustment, and we could have set this at 100 megahertz, and we could have tuned the stereo to 100 megahertz, and we could have done that whole same thing with the Lissajous pattern, with the multiplex, everything at 100. Okay, same thing. You have your 19 kilohertz subcarrier, and you can even adjust the level of output. Okay, you can turn it off or on from here. You can even set up a sweep signal to test your FM modulation. You can make all of your key frequencies for this, so you can have your 38 kilocycles, your 19, you can have your audios, you can have the 67 and 72 if you want to do the SCA. SCA is subcarrier access, which is another broadcast that could ride on top of a radio station. It's kind of like having two channels on one frequency. All they did was expanded that modulated carrier out to almost out to 100 kilohertz, and you could put like another audio track. You don't see too much of that anymore. That was popular a long time ago, but you don't see too much of that. And it even can set up your left and right modulation. Okay, sweep. So pretty much this one little piece of test equipment could do everything that we just did. And guess what? Most people don't even know what these are, and when they pop up on eBay, I think when I bought this, it was a long time ago, but when I bought this, I think I only paid $30 for it, something like that. It's a very overlooked thing, and here's the real kicker about this, and this is why I brought it out to show you. When I took this thing apart, this thing's 50 years old or more. When I took this thing apart, it was immaculate. Every capacitor inside this unit is original, including the electrolytics, and they are absolutely like the day they were built. I know some of you won't believe that. I can't hardly believe it. The resistors were dead on, and this thing was almost perfectly aligned. Almost. And I literally just, and I'm talking, I was using this down here, the spectrum analyzer, to set my frequencies on peak, and I'm telling you, just the tiniest little bit of trimming the alignment for each and every one of these, it was right on. So this is a great piece of test equipment. If you get your hands on one, I highly recommend it. For those of you who don't think you can afford FM equipment, this is the one you want. Shop around, you'll find them. Well, there we are on AM. Using the little radio station here. Pretty cool, the Talking House. You guys can look those up online, they're pretty cool. But
That's very nice. Be with us tonight. Well,
got our AM tuned up, got everything shined up, and wow, this one turned out really nice. So I guess we'll do one last thing, and we're going to call this video a wrap. I'll hook it up to the test equipment, and we'll take a look at what our output performance is on this. I'm not going to do a listening demo on this because it's just too much hassle for me to hook everything up over there on the big speakers, but at least we can see what kind of maximum power we can get out of this, and you know, if it's nice and clean and so forth. So let me hook that up, and we'll be back.
I've seen it.
Well, we're gonna blow the feathers off of that thing, and we're gonna finish it, and gonna look like a big.
Okay, I'm gonna go handheld on this one. As you can see, we have our oscilloscope set up. We have our voltmeter set up. Signal generator 1 kilohertz, 250 millivolts output, RMS, into the auxiliary inputs, going into our dummy resistor load, coming out of our scope ports and going up into the scope. So I'm going to adjust the volume here, and we're going to see how far we can get it before it clips. So let me zoom in a little bit. Excuse the shaky camera. Right about there's where we're starting to clip just a little bit. And if we look there, 33, a little bit less, 32.6. Okay, so let's get our calculator here. 32.6 times 32.6 divided by 8, 132 watts, 132.8 watts per channel. For a 120 watt receiver, I would say that's pretty darn good. Now, if we used our THD multimeter and we measured the actual distortion, there would probably be some distortion in there that we weren't seeing on the scope, so technically it might be a little less than that, because these are really rated at pretty much no distortion. So even with that, that is inaudible distortion. You wouldn't be able to hear it unless you have really good ears, which aren't as good as mine. But this is a 130 watt receiver, let's call it. Now let's move it to a different frequency. So let's take our frequency and we'll change it to, let's say, 50 hertz. Oops. Cancel. Frequency. 50 hertz. Copy. Align. All right. And of course we're going to have to slow this down just a little bit. And let's see. Even that we got to slow down a little more. Okay. And we're getting right. Same thing, around 32. If you look up here. Let me back it off till it's all gone. About 32 volts. So we got our same roughly 130 watts there. Now let's go to 20 kilohertz. Okay, copy, line phase, and we're gonna have to really crank that up. And let's see if we get our 32 volts here. That's 20 kilohertz, guys. And right there we're starting to really kind of break up. 32, 33 volts, actually a little hotter. Closer to 140 watts. About 130 watts again. So, yeah. And let's go way down to 15 hertz. Okay. And this is going to be really choppy looking on the scope. Let's see if we can get it to show up with a neat waveform here. So far so good. Right there's 130 watts per channel at 15 hertz. Right there, man. 32.26. There it is. There it is. That's pretty loud, man. So again, I am going to say that this is one really nice receiver. I want to play around with this bass to see how we affected it by making that little change. But in order to do that, I'll have to connect that to a big set of speakers that really gets the low end. But we'll play with that later. But generally, there it is. Sorry that this video wasn't quite as fancy as the last one, but things have been really crazy at work lately, and I'm just lucky to have the amount of time that I did to finish this up. I hope I cleared the water for some of you with multiplex and gave you a few ideas to get started on your own with it. And for those of you who are just curious, I hope that cured your curiosity. But regardless, I thank all of you for your many kind words once again, and give us a thumbs up if you like what you saw. And I can tell you there's a whole ton of things coming here, and not just audio, but there's a whole bunch of different things that I have coming across the bench here. So that's it for now, and till next time, take care and thank you for watching.